We now have a minimally functional game that allows us to place towers on a map and fire at enemies that are in range. But we still don't know the difference between the two main types of objects that we've used so far. They both achieve the same end goal in that we can represent complex data types. Well, worry no longer, because we are about to take a look at inheritance.
Our little game is kinda cool so far, but in real games like this, as we progress through the levels, the enemies get progressively harder. Right now, our enemy's life property has a value of 2, which means that when in range, it only takes 2 shots for a tower to get rid of it. We want to introduce a much stronger enemy that can last longer against a tower. How do we go about this? Well, we could write a new class called Super Enemy. So let's try this. We'll go back up, and right after the class declaration for enemy, we'll add a new one. So we'll just add a comment here. We'll say enemies, and here we'll say towers. Okay, so right after enemy, we're going to add a new class called Super Enemy. This Super Enemy class is going to have the exact same properties, initializers, and methods. So from inside enemy, we can just copy-paste the body into Super Enemy. Now, the only thing we want to change is we want it to have a stronger or much longer lifespan, so we'll give the life a value of 50. Everything else remains the same. Okay, now what if we wanted a really tough enemy? Okay, well, we can create another class. We'll call this Really Tough Enemy. Note that this is purely for the sake of examples. These aren't good class names. So again, here, we want to do the exact same thing, except this enemy is much stronger. So we'll paste the same code in again, and now we'll give life a value of 100. You'll notice, though, that in doing this, I'm violating a foundational principle. Earlier, we talked about the dry principle. That is, don't repeat yourself when writing code. We're repeating ourselves quite a bit. The only thing that's different in Super Enemy and Really Tough Enemy is the value of the life property. Everything else is simply repeated code. Now, luckily, we don't have to do that. Classes support a mechanism known as inheritance, and this is one of the fundamental ways it differs from a struct. Let's write some code first, and then we'll talk about it. So we're going to get rid of Really Tough Enemy, and we'll get rid of the contents of Super Enemy. We'll leave that class declaration. Now, go over to the line where we start the class declaration for Super Enemy, so line 58 for me. Place your cursor right after the name, and then type out a colon, add a space in there, and then say enemy. Now, our Super Enemy class inherits from the enemy class. What does that mean? It means that now the body of Super Enemy is identical to enemy. We just don't have to type it out. To see if this is true, let's go back to the bottom and let's try and create an instance of Super Enemy. So we'll say let Super Enemy equal Super Enemy. And you'll notice that once I type the open parentheses, we have the same automatic initializer for it that we created earlier. Now, this isn't because one was automatically created like a struct, but because we inherited the initializer that we wrote for the enemy class. When we talk about class inheritance, we're essentially saying that the interface or the implementation or the body of the class is same for both these classes. So Super Enemy and enemy have identical bodies inside the braces. So same initializers, same properties, same methods, and so on. A class can inherit methods, properties, and a few other characteristics from another class. When one class inherits from another, the inheriting class, which in our case is Super Enemy, is called the subclass. And the class it inherits from, enemy, in this case, is known as the superclass, or sometimes the parent. The first advantage of inheritance is that we can avoid code duplication, as we just saw. The second advantage is that we can refine the subclass and either modify existing properties or add new ones. We want the life property on Super Enemy to have a value of 50 because this enemy is far stronger. Typically, when we give stored properties a value, we just declare the property inside a class definition and give it a value, right? Well, we can't really do that here, not in SuperEnemy. Before we get into why though, let's take a quick break and test our knowledge before we move on.